So we've talked about some of the things that have led up to the 20th century skyscraper in particular. And we've looked when we were talking about 19th century skyscrapers, we looked at the kind of removal of the structural function from a building's exterior walls. So for thousands of years, the assumption is always that when you build a wall, that wall is not only there to keep the rain out, but it's also holding the building up, right? Masonry walls in particular. But we saw that as we were able to kind of distill all of the structural functions, gravity loads and lateral loads, onto a self-supporting steel skeleton, that in the 1890s especially, exterior walls could become much, much lighter, much, much thinner, and they could lose the structural function that kind of bulked them up, that took space away from windows, and instead just really be about enclosure, right? Keeping the rain out. And in fact, if you think about it, we could go even further back than the skyscraper lecture. Viollet-le-Duc, in his discourses, basically came up with this recipe for what we now think of as modern construction. In other words, exterior walls that are simply enclosures, simply keeping the climate separation between indoors and out, and not doing anything in terms of the structure. In fact, relying on the structure for their own support. Viollet-le-Duc says that if you think about a skyscraper, a vast edifice whose frame should be entirely of iron, and then clothing the frame with a casing of stone, right? An interesting choice of terms. If you encase an iron structure within a shell of masonry, that shell must be regarded only as an envelope. We might say today only as a curtain, having no function other than supporting itself without lending any support to the iron or receiving any from it. We've seen a couple of examples of this too already. The Crystal Palace, for example, basically followed Viollet-le-Duc's formula just before he'd actually written it. And of course the Crystal Palace did this in glass instead of stone, glass and iron, if we're fair. But the skin of the Crystal Palace, of course, had no supporting function, couldn't, because it was fragile glass. It was literally just about making an environmental separation between inside and outside. All of the structural function took place on the iron frame within. And we see a couple of examples of others who think through the consequences of the iron frame, later, of course, the steel frame, and realize that putting all of the structural responsibility onto the frame leaves you with enormous possibilities in terms of the skin. The skin can become thinner, which means that you can rent out more space within, or at least use more space within. And the material choices on the skin can be much broader because you no longer have to worry about the skin being structurally capable of carrying the floor loads within. Here, for example, a builder in Chicago named Frederick Baumann, who writes a pamphlet in 1884 called Improvement in the Construction of Tall Buildings, Truth in Advertising. A lot of what Baumann suggested had to do with foundations, and particularly the foundations in Chicago. But along with this, Baumann realized that lightweight construction, thinking of the skin as a curtain instead of as a structure, would help his cause in trying to perch these buildings on top of fragile, delicate foundations on Chicago's clay soil. So here he gives a dozen or so points that he calls the concealed iron construction of tall buildings. And he says that if you build a skeleton of iron on the one hand and a hull of iron or a cladding of iron on the other, then you gain all of these possible benefits. Firstly, the enclosure, be it stone, terracotta, or brick, may be erected from without. In other words, you have greater flexibility in the construction sequencing of it. You can bring in more light, even in the lowest, most valuable stories, where otherwise the necessarily broad piers, he says, would be a hindrance. Think of the walls of the Monadnock building, right, getting really, really big because of all the load, the exponentially greater load that they're carrying above them. And then the iron itself would have this set of brackets, or today we would call it a kind of substructure that you would anchor and support the parts forming the exterior enclosure to. So there's a kind of specialty set of connections that lets you hang this very, very lightweight skin onto the iron structure. And he says what's kind of amazing about this is that you could take out any piece of the exterior lining and put it back, right, if it had been damaged by fire or otherwise. So Baumann here is talking about what we would today think of as an absolute curtain wall. And we have seen a couple of skyscrapers in particular that seem to be getting very close to this. The Reliance building in 1895 is a structure that the German modernists in the 1920s will look at as really a forerunner to what they see as the modern industrialized curtain wall. And this again is a building where the skin is held up on these cantilevered brackets that you see in the center drawing, letter B. That's the steel bracket that is reaching out from the column, holding up the terracotta and glass skin on the exterior. 66% glass, so a pretty amazing amount of transparency, and one that even though the expressionists and modernists look at all of Atwood's Gothic ornament and sort of recoil in horror from that, they see the tectonic potential here as a kind of forerunner to what happens in the 1920s. There are other examples of using lightweight iron and glass as a skin or a curtain, a non-structural, non-bearing element of the building. This is Victor Horta, the Maison du Peuple in Brussels, which is very, very much in line with Viollet-le-Duc's suggestion, right, that there is an iron skeleton within. And on the exterior, this is a cladding of very, very minimal stone coverings for the structure. And then, as you can see, nothing but iron and glass between them, right? A really remarkably transparent facade, even more so than the Reliance. And there are very functional ways of doing this as well. Department stores. We saw Sullivan's Carson Perry Scott, where these gigantic plate glass windows enable people to see the merchandise inside while bringing in daylight to show off the merchandise in its best light. Here is a well-known department store in Paris, Saint-Martin, which is finished in 1905, and again features a stone and glass curtain wall designed to bring in as much daylight as possible while showing off what's going on the interior. Curtain walls turn up in some unexpected places as well. An argument for one of the first all-glass curtain walls is in Kansas City, Missouri, of all places. This was a clothing building, so a retail store that had some of the same functional desires as Saint-Martin, right? Wanting to display the merchandise, or at least give you a hint of what was going on inside. So this is plate glass in the vision panels, and then iron in the spandrels. So again, a complete glass and iron facade with this terracotta ornament that kind of wraps it. And that terracotta ornament, as you can tell, is there pretty much strictly for architectural reasons, right? To give the building some visual solidity. It's no longer necessary to have the solid there as a constructional or a structural necessity. It's there strictly for visual purposes, and the glass curtain wall is really now doing most of the work. And maybe slightly more famously, 8 or 10 years later, Willis Polk, who comes from Burnham's office in Chicago, so with a good knowledge of the Reliance and Fisher buildings, sets up shop in San Francisco, and among other things, designs this building, the Halliday building, which is all glass on the exterior. And you can see that the floors on the inside, a concrete structure, they cantilever out. They hold the structural mullions, the iron mullions, and between those mullions there is literally nothing but glass. So this is approaching kind of 90-95% glazed on the exterior. These are often seen as kind of functional ideals. Polk is trying to bring in as much daylight as he can. As it turns out, he brings in too much. This is a building that's had, as you can imagine, glare and cooling problems ever since it opened. But the curtain wall also begins to be seen as an architectural innovation. And it is precisely those kind of second or third generation German arts and crafts respondents who take the curtain wall forward as an architectural expression. And we looked at two of these, the Factory on the left by Walter Gropius, where the glass curtain wall is used not only to bring in daylight, but also on the left side of the photograph to really be part of an architectural composition. And Gropius very conscientiously designs the curtain wall to have a glass-to-glass corner so that you see that the wall is not structural, right? That the floor slabs are being cantilevered, or really double cantilevered, and that staircase behind the glass wall is clearly there as part of an architectural composition that has more to do with a sense of lightness and airiness than it does with any sort of functional need for that much daylight in a fire stair. On the right, Gropius's Bauhaus building in 1926, where he takes the same idea of using the glass curtain wall in a corner to really establish the fact that the slabs are cantilevered, that there's no support whatsoever on the exterior. And you can see even today, though the building has been renovated and had all sorts of environmental work done to it, you can see the problem, right? All of the curtains are drawn even on what looks like a fairly cloudy day, right? That the all glass curtain wall has some environmental issues. A slightly less well-known version of this is in the UK, an engineer and builder named Owen Williams, who in 1930 designs a warehouse for the Boots Pure Drug Company and does this, not strictly a curtain wall, right? This is what we would call a storefront. So it's going just slab to slab, and the slabs are then expressed on the exterior, but still an all-glass facade that brings in, again, enormous amounts of light, offers advantages in terms of the prefabrication and the quick assembly on the job site. And Williams, even though he's an engineer, not an architect, clearly recognizes the aesthetic potential of this and integrates the idea of this pure transparency into the facades of this factory building. Now, maybe nowhere is the enthusiasm for glass more evident than in Mies van der Rohe's glass skyscraper projects. These two unbuilt projects, the one on the left, a competition for an office building on the Friedrichstrasse in Berlin, and on the right, something he does more or less on his own for an office tower in the suburbs of Berlin. You can see the scale of the buildings around it in the photo montage. And for Mies, the glass curtain wall is one tool in his toolbox that he can use to achieve what he calls beinahe nicht, or almost nothing. He is after an architecture of transparency, of ephemerality, of almost not being there. And the kind of character of his work throughout his career is to try to reduce architecture to its bare minimum. So a skin that is almost literally invisible is something that very clearly Mies is going to want to work with. And it's interesting to look at how he described these projects when he wrote about them. They were published in a German magazine called G in 1922. And he says about the glass skyscrapers, "Never before did man succeed in enclosing and dividing up space by a single membrane, but only with certain qualities of a solid wall, such as defense against temperature variation and noise." He says, echoing, I think, Viollet-le-Duc, "There's evidence of a new structural concept where all load-bearing elements are kept within the core of the building, leaving the outside wall free to be nothing but a wrapping to enclose and allow light to penetrate." So he's writing this as a kind of revolutionary manifesto. He's about 50 years late to the party, right? This is something that Viollet-le-Duc discussed. This was something that Baumann discussed. This is something where we can see these kind of proto-curtain walls happening long before Mies van der Rohe comes up with this kind of aesthetic rationale or this theory for them. As we've hinted, the glass curtain wall has some very serious drawbacks. And these are made evident in a lot of these early projects, but maybe most notably in this dormitory building by Le Corbusier in Paris in 1928. The Cité de Refuge is a dormitory, it's a Salvation Army dormitory for homeless men in Paris. And you can see in the original that Corbusier has the same sensibility as, say, Owen Williams or Willis Polk, that the glass wall has some real architectural potential. Maybe not quite the minimalism of Mies, but part certainly of an industrial collage of materials and forms. The glass wall that he designs opens up the dormitory rooms to the exterior, but unfortunately does it to the southeast. And as we know today, it's a sort of cardinal environmental sin to face a all glass facade without any shading toward the southeast. The dormitory rooms prove, not surprisingly, to be unlivable. And a few years later, Corbusier has to come back and install this set of brise-soleil, or that's French for sunbreaker, these shades on the outside that protect the glass from direct sunlight in the mornings, or at least say after maybe mid-morning, keep a lot of the solar gain out. For Corbusier, as we'll see, this is transformative. The brise-soleil goes on to become one of his signature elements in his building facades. For others, though, it is a kind of warning sign that one has to be careful when deploying this huge, vast expanse of glass over buildings that typically at this point are still not air conditioned. Air conditioning has come online. It's been proven in commercial use in the Milam building in San Antonio in 1922, among others, but it's certainly not yet economical for, say, a dormitory for homeless citizens, right? This is a building that has to rely on natural ventilation and therefore really needs the extra effort of a sunbreaker or solar shading on the exterior to make it work. The other thing that sort of gives architects pause, or that limits the application of the all-glass facade, is fire. And it's not so much that the glass facade is going to allow fire to spread in the way that people are maybe worried about it. It's certainly possible that with a flimsy or thin skin on the exterior, that you'll get a fire on one floor that bursts through the skin and then affects the floor above. But combined with that, or maybe more serious than that, is the fact that building codes, fire codes up to this point, have just assumed a solid wall. And we can see this again looking at Chicago. This is as late as 1941. The Municipal Building Code of Chicago has this clause in it that says that every window, this is at the bottom here, 65.8, every window in a non-combustible wall shall have a non-combustible sill and spandrel equivalent to 2-hour fire-resistive construction for not less than 3 feet between the window and any opening in the story below. So the code here is what we call a prescriptive code. It is demanding exactly the way to design the building. And it's not giving architects any room to experiment with a floor-to-ceiling glass wall, say, because it's requiring what we today call, or what's called then, a spandrel wall, right? A wall that sticks up, that presents a solid face to any fire that's trying to come back into the building. And you can see other examples of this prescriptive approach that if you have, for instance, a fire-resistive wall that has to have 4-hour thickness, the code tells you exactly what you have to do. It's not what today we work with are called performance codes, where you have to just prove that the wall type that you're using can resist fire for however many hours. This is actually telling you exactly the materials that you're allowed to use. What does that mean architecturally? It means that even when architects specify all glass facades, for a long time, well into the 1950s, many of these facades are built in cities that still require these fireproof spandrel walls. This is a well-known curtain wall in London, the Daily Express building that the architects are Ellis and Clark. Owen Williams, who did the Boots factory that we looked at a few slides ago, is the engineer. And you can tell, I think, that Williams' experience with curtain walls definitely has an impact on this project. The facade is all glass, but it is clear glass where there are offices, and below the sill level, it is vitrolite or solid glass. That is the black glass that you see in the facade. And when you look at a section through the building, what you realize is that the concrete slabs have been turned up at the edges. This obviously has some structural benefit, right? It makes for a stiffer edge slab. But of course, it puts these gigantic 3-foot-high barriers between the offices and the exterior. This is also part of the fire code that London is under at the time. And the need for a fireproof spandrel, 3 feet tall, reflects the fact that the codes just assume that exteriors of multi-story buildings are going to mostly be solid, right? Solid stone or solid brick with windows sort of carved into them. Even in the United States, even on what's probably the most technologically advanced skyscraper project in the world in 1932, the Empire State Building. You can see on the left that the spandrels, the dark patches between the windows and those long vertical stripes, are actually spandrel walls, right? They're actually firewalls that, again, are demanded by New York City's building code and will be demanded by New York City's building code well into the 1960s. New York City is one of the last major cities to accept the floor-to-ceiling glass curtain wall as a legitimate, reasonably safe way to clad a building. You can see on the left that this era of buildings in the 20s and 30s very often combines that spandrel wall with a radiator. Right? You can see just behind the masonry wall that there is a radiator here. And it has a kind of cabinet that blends with the column, blends with the spandrel wall. But all of this brick in here is non-structural. It's simply there to satisfy the fire requirement from the New York City Building Code. Here in Chicago, another one of these very advanced buildings, but much later than the Empire State, the Prudential building, the first big skyscraper built after the Depression in Chicago. Modern in massing, right? Asymmetrical, kind of a streamlined, boxy aesthetic to it. But when you look at the detail of the skin, what you realize is that the skin has these spandrel walls that not only go up, but also come down in front of the structure. They're clad in stainless steel, so they feel like part of the window stripes on the building. But when you look closely at the section, you realize that the section of the window is almost exactly the same as that of the Empire State Building, right? A whole generation earlier. So the code is really kind of holding back the development of the all-glass curtain wall. And you can see it in the comparison between buildings from 1932 and, in this case, 1954, right? That the code is really requiring architects still to work with solid walls with sort of punched windows in them. Maybe most dramatically is the first high-rise that Mies van der Rohe actually builds. He comes to Chicago in 1937. He is a refugee from the Nazi takeover in Germany. He settles in Chicago, teaches at Armour Institute, what will become the Illinois Institute of Technology. And in the midst of doing all of the buildings for the new campus of IIT, he gets this one high-rise commission for an apartment building on Lakeshore Drive near the University of Chicago. And you can see that the glass skyscraper architect is sort of hamstrung, that the building code in Chicago requires these upstand walls, And so Mies is really left with exposing the concrete frame, which he thinks is legitimate, right? A sort of honest expression of what the building structure is. And then filling in that frame as much as he can with glass, right? This building has as much glass as the code will allow, but you can see that it doesn't allow him to produce the floor-to-ceiling glass curtain walls that he'll become known for fairly quickly. There are a number of things that happen in the 30s and 40s that make glass not only an ideal architectural choice, but that make it a good economic and eventually even a good environmental choice. We'll have a look at those in the next piece of the lecture, and we'll see how Mies takes advantage of those very quickly within a few years, almost exactly the same program on a very similar site, but with very, very different outcomes.